Section 12.4 is on volumes of prisms and cylinders. The formula for the volume of a prism is given by V equals B times H, where B, that is capital B, is the area of the base, and H is the height of the prism. And recall that the height of the prism is the distance between the two bases. Let's take a look at an example here. A couple examples. Let's find the volume of each prism. Here we have a triangular prism, and notice that again the base is not on the bottom. The bases are the parallel congruent faces. So the base is actually a triangle. It's a triangle that looks like this. And I'm going to go ahead and draw it in 2 dimensions. This is 6 centimeters, and the height is 4. So my formula, volume equals area of the base times the height, first thing I need to do is find the area of that base. So my base is a triangle, so I'm going to use the formula 1/2 base times height. Now again, don't get confused. Big B means the area of the base. Little b here refers to the linear length of the base of the triangle. So 1/2 times 6 times 4, or the area of this base is going to be 12 centimeters squared. Now also don't be confused by this H in the formula down here and the H in the formula up here. This H refers to the height of the triangular base. This H refers to the height of the prism, which is the distance between the two bases. And in this case, the distance between the two bases is going to be 9 centimeters. So big B is 12. Distance between the bases is 9. So the volume of this triangular prism is going to be 108 cubic centimeters. Cubic because it's volume, because we're actually multiplying 3 different linear lengths, linear dimensions. This is a trapezoidal prism. The base is a trapezoid. Trapezoidal prism. So my base is going to look like this. You can draw it in 2 dimensions if you need to. And it doesn't have to be super exact. So my shorter distance, so in this case the trapezoid is on the top and the trapezoid is on the bottom. So here's a 7, this is 15, and the height here is 3 inches. Now I don't think I drew that to scale, but anyway. So the area of this base, big B, is going to be the area of a trapezoid, which is 1/2 times the height of the trapezoid times the sum of the bases of the trapezoid. Now there's a lot of H's and B's running around here, so don't get confused. Right now I'm just working on the area of this trapezoid. Or 1/2 times 3 times 7 plus 15, or the area of this is equal to 33. So that's the area of the base. So to find the volume is going to be big B times H. Big B is 33. Now this height is not 3. The height, this H right here, refers to the height of the prism itself. How far apart is the trapezoid on the top and the trapezoid on the bottom? And that would be 12 inches. So my total volume is going to be 396 cubic inches. The volume of a cylinder is given by the formula V equals pi r squared h, where r is the radius of the base, and remember the base of a cylinder is a circle, and h is the height of the cylinder. And actually, to take a look at it, this formula is pretty much the same as the previous one. Pi r squared, that's the area of a circle. The base is a circle, so basically you're just multiplying the area of the base, which is a circle, times the height of the cylinder. Let's take a look at a couple examples here. So here we have a cylinder, and the radius is 3.7. The height is 4.8. So I'm just going to plug those into my formula. Volume equals pi r squared h, or pi times 3.7 squared times 4.8, or the volume is approximately equal to 206.4 cubic feet. Cylinders usually are pretty straightforward. Here's another example. Here I have a cylinder, and I notice that the diameter of the base is 5, but then I have this slanted distance inside the cylinder. So this is another good time to draw the triangle on the inside. So I have this right here, which is actually going to represent my height. Here's my 13, and this across the bottom is 5. So this here is my height. 5 is the diameter of the base, and 13 is that slanted line going through the middle. So using the Pythagorean theorem, 5 squared plus h squared equals 13 squared, I get that my height is equal to 12. Now, since the diameter of the base is 5, that means my radius is going to be half of that, or 2.5. So my volume, pi r squared h, is going to be pi times 2.5 squared times 12, or my volume is approximately equal to 235.6 cubic inches. So sometimes with a cylinder, you can also have a triangle on the inside where you may need to find one of the missing measures. And the last concept here is an oblique solid. An oblique solid just looks like a regular solid that looks like it's been pushed over. Its base is not perpendicular to an edge. So here's like a cylinder, and basically if you were to keep the bottom where it is and push the top over, you'd get an oblique solid. What you need to know about its volume is that it's the same as the volume of a right solid. As though it were straightened up, the volume is going to be exactly the same. You will notice, however, that the height could be outside of the solid itself. So let's take a look at an example here. Here we have an oblique hexagonal prism. So it's like a hexagonal prism that's been pushed over, and we need to find its volume. So volume is the area of the base times the height, and we actually kind of lucked out on this one. We don't have to find the area of that hexagon. That's given as 17.3, and my height is this distance here. It stays the same. You know, it's still the distance between the base on the top and the base on the bottom, 6.4 centimeters, or that comes out to 110.72 centimeters cubed. So, in this lesson we found the volumes of prisms and cylinders, some pretty straightforward, pretty easy formulas, and again, the difficult thing might be finding the area of the base, and if necessary, draw it in 2 dimensions, and if you need to, draw that triangle on the inside as well.